Hello and welcome back. In this tutorial, we will talk about exponential functions. Exponential function is the function of the following form. Y equal a to the power of x, where a is greater than 0 and a is not equal to 1. A is called base of the function and x is the variable of the function. If base is greater than 1, then the exponential function will be increasing exponential function. So the graph of the function looks like that. If base a is between 0 and 1, then exponential function will be decreasing and the graph will look like that. Exponential functions are very nice functions. The range of this function, as you see, will be from 0 to positive infinity. Exponential function will never intersect x-axis. So range is from 0 to positive infinity. And domain, as you see, it will be the whole real line. Whenever I pick point x, I always will meet the function a to the power of x. So domain is from negative infinity to positive infinity. Any exponential function passes through the same point, 0, 1. So if, for example, we construct some graphs of the functions, let's say 2 to the power of x and 3 to the power of x, no matter which base I have, the function will always pass through the point 0, 1. If we wanted to construct function with base between 0 and 1, we will just take this function, exponential function, let's say 2 to the power of x, and flip it symmetrically over y-axis. So my function 1 over 2 to the power of x will become just symmetric function to 2 to the power of x. And function 3 to the power of x, symmetry will give me 1 over 3 to the power of x. As you see, no matter which base I have, all exponential functions passing through the same point. This is a very nice property of the exponential function. Also, you can notice that if base is getting bigger, as more rapid exponential function is. So exponential function is the fastest function you can ever get. If you wanted to explain some nature in the real life that something happening very, very fast, we will also always say that it's exponential decay or exponential race. In applications, it's very important to have some exponential function which is easier to work with. And the engineers and people in science always ask, what will be the exponential function or which base of exponential function we can take? So if we construct a tangent line at this point where a function intersect y-axis, point 0, 1, and this tangent line would have slope m equal to 1. Well, apparently, this base can be found, and it took probably 100 years to figure out what this base would be. And mathematicians find that this base A should be equal to the following number, 2.71 approximately. And this number is always called E number. So in other words, we would be working with the following function, y equal e to the power of x, where e is just a short notation to the number, approximate number 2.71. It's like number pi, short notation for 3.14, the same notation we have for number e, 2.71. Let us look at some laws of exponential functions. If we wanted to multiply two exponential functions with the same base but different powers, let's say a to the power of x times a to the power of y, we would do this in the way that we take the same base a and we just add the powers. So it will be a to the power of x plus y. Same with division. If we divided a to the power of x by a to the power of y, in this case, we just subtract the powers. Now, if we wanted to raise exponential function a to the power of x to the power of y, this is the same as we're multiplying these powers. And I can interchange multiplication. It's the same as a to the power of y times x. So it would be the same as I would take exponential function a to the power of y and raise it to the power of x. Another nice property we have is just a to the power of 0. Anything to the power of 0 always give us 1. And one more property which is important for solution of equations is that a to the power of x is equal to a to the power of y whenever x is equal to y. This allows when we work with the same base of the exponential function, base a. What happens if we have few different bases? So if we have, for example, exponential function a to the power of x times exponential function b to the power of x. You see, bases a and b are different, but the powers are the same. This will be the same as we would multiply bases and raise them to the same power of x. Same with division. A to the power of x over b to the power of x is equal to a over b, everything to the power of x. These are laws of exponential function. Let us look at some examples. Let us simplify the following relation. 2 to the power of x times square root of 16 to the power of x divided by 4 to the power of x. I wanted to simplify this relation using exponential laws. Look, 16 to the power of x I can represent as 2 to the power of 4. So 2 to the power of x times square root 16 can be represented as 2 to the power of 4, and then we raise it to the power of x. Everything divided by, now 4 I can represent as 2 squared. So we have 2 squared to the power of x. Now I can simplify. 2 to the power of x times 2 to the power of 4x to the power of half, so square root can be represented as power half, divided by 2 to the power of 2x, which is the same as 2 to the power of x times 2 to the power 4 over 2 give me 2x divided by 2 to the power of 2x equal to, now I have exponential functions with the same base but different powers. So I can write it by law of exponential function. I can write it as one base and sum of the powers. So it's 2 to the power of x plus 2x. And now I have division, which I can write it as negative 2x in the same power. So I obtained 2 to the power of x. So this relationship, 2 to the power of x square root of 16 to the power of x over 4 to the power of x, can be simplified as just 2 to the power of x. Let's do another example. Let us solve the following equation. 2 to the power of x minus 1 is equal to 4. By the property of exponential function, we have that a to the power of x equal to a to the power of y whenever x is equal to y. And this is only property we know for the equations. So what we have to do here? We have to represent both sides of this equation in the way that we can use this relationship. In other words, we have to represent 4 in terms of 2 to some power. So 2 to the power of x minus 1 would be equal, and now 4 I would represent as 2 squared. Now, using property of exponential function, we can say that since we have the same basis, the powers have to be equal. And we obtained very easy relationship between x minus 1 equal to 2. So from here, x would be equal to 3. Another equation we can try is the following. 5 to the power of x squared plus 2x plus 1 equal to 25. So again, I wanted to represent both sides of the equation in the way that I have the same base. So as you see, 25 can be represented as 5 squared. What I obtained now that base 5 to some power equal to base 5 to another power. So since bases are equal, we can make the powers equal. We obtained x squared plus 2x plus 1 is equal to 2. And now it's only left to solve this quadratic equation. So we can simplify it. X squared plus 2x plus 1 minus 2 will give me minus 1 equal to 0. Now we have to use discriminant formula. x1, 2 would be equal minus b, which is minus 2, plus or minus square root of b squared, which is 2 squared, minus 4 times a, which is 1, times c, which is minus 1, divided everything by 2a, 2 times 1. So now if we solve this, we obtain that x1 would be equal to minus 2 plus square root of 8 divided by 2, and x2 will be equal to minus 2 minus square root of 8 divided by 2. And this would be solutions for this equation. Now it's your turn to practice.